everyone, I am Pankaj Singh welcoming all of you on the Drishti online platform for the 100 most important topics for UPSC Prelims 2026, and it is the 12th episode and it is very much important for your exam upcoming this year. And now next to start with, I said that in the last classes we have done the 11th episode, some questions I have given you, and accordingly I said that I am going to answer it, and those answers will be only answers. I am trying my best to somewhere some explanation can be given by me, but what is your need is to that you have to see that some question, suppose I am giving this is the answer, if you are not able to understand, so go and see the 11th episode of videos again, so that you can be able to understand why this answer is. So we are moving toward this. Is in the 11th episode we have seen that what is El Nino, normal condition and its impact on monsoon, normal Walker circulation or oscillation, and what happens during the El Nino, and El Nino impact on Indian monsoon, and La Niña and its impact on Indian monsoon. So here we are going to see that this question, consider the following statement regarding El Nino. It is characterized by abnormal warming of sea surface temperature in the central and eastern Pacific, equatorial Pacific Ocean. Yes, in the eastern and central, this statement is you can say that this statement is correct one. It is purely an oceanic phenomena and does not involve atmospheric challenges. So we can say that it is involving atmospheric changes also, not only it is this one. And yes, the second statement we can say that it is wrong one, because it is also involving the atmospheric changes. And then second one, third statement we are saying it is a phase of the El Nino southern oscillation. Yes, it is the phase of El Nino southern oscillation. That is or you can say that it is a warm phase. La Niña is in a cold phase, it is in a warm phase of El Nino southern oscillation. And on the basis of that one, we can say that option 1 and 3 it is correct. And now that here we are going to see in this, consider the following statement regarding the normal Walker circulation. The trade winds blow from east to west across the equatorial Pacific Ocean. Yes, the trade winds are moving, northeast trade wind, it is coming from east to southeast trade wind coming from east to west, and that is a correct statement. And then cold upwelling occurs along the western Pacific coast near Peru. Western Pacific, near Western Pacific, Australia and Indonesia is there, not Peru. They here, but yes, cold ocean occur near Peru, it is in the eastern Pacific. So this written western Pacific, it is in a wrong one. And so this statement is wrong, that rising air current dominant over the eastern Pacific and the rising air. So on the western Pacific, if we can be able to say that in this during the normal Walker circulation, western Pacific is in a hot and warmer water, it is there near Australia, Indonesia. Here the rising air on the western Pacific, not on the eastern Pacific. Eastern Pacific cold water upwelling is there. So here you can be able to say the rising air currents along the eastern Pacific, not it is in a western Pacific. So that on the basis of that one, this statement is also wrong, and we can say that C, option 1 only is correct. So next one, I say that with reference to the normal condition influencing the Indian monsoon, consider the following statement. With respect to the what I said, that normal condition, yes, normal condition it causes good rainfall in India. So here the extension of Walker circulation which is taking place over the normal condition, that is in a warm ocean near Australia and Pacific. The extension of Walker circulation toward the Indian Ocean contributes to the low pressure over the Indian subcontinent. Yes, this is the right, because that Walker circulation where Australia and Indonesia is warmer in the Walker circulation, and it is extended toward the India also, and therefore India is in a normal which attracts more Indian land mass is warmer, and it attracts more warmer means low pressure, therefore it attracts more monsoon moisture or southwest monsoon, and from the Bay of Bengal and Arabian Sea and all. So and the second statement is strong land sea thermal contrast during summer enhances monsoon. Yes, if the land become warmer, so there is a temperature is more, and the relatively ocean is colder, then the temperature contrast is more, and then this statement is again correct. Strong land sea thermal contrast summer enhances monsoon circulation. Moisture laden monsoon winds originate from both the Arabian Sea and Bay of Bengal, and it is causing, yes, the moisture is coming from both the regions, even from it is coming from the Indian Ocean, so South Indian Ocean. So this statement is correct, and we can say that option D, 1, 2 and 3 are correct. And now we are going to see it is the next one. Consider the following statement regarding El Nino condition. the Walker circulation is strengthened due to increased pressure gradient. So Walker circulation, you know that it is in a strength, and the pressure gradient is also you can say that it is in a more, and here during the El Nino you can be able to say that Eastern Pacific near Peru coast is a warmer, and I said that Western Pacific is relatively colder, so there is a pressure gradient is there. So increase the Walker circulation is strengthened, but in this one Walker circulation should reverse. Walker circulation should reverse, or you can say there is a weak Walker circulation. So strengthened is not there, it's a wrong one. Pressure gradient is happening, but strengthen is not taking place. This statement is wrong. And warm ocean water shifts from the Western Pacific towards the Central and Eastern Pacific. Yes, during El Nino that it is going towards that region. So warm ocean water shifts from the Western and Central Pacific towards the Central. This statement is right. Yes, it is moving to the Central and Peru coast, this warm during the El Nino year. And another one, I said that upwelling along the Peru coast becomes stronger during El Nino. When the El Nino water is there, it is in a warm water in the Eastern Pacific, so upwelling will not place, it will suppress the upwelling. So upwelling along the Peru coast does not happening, yes or not? So this statement is wrong. So we can say that option B 2 only is what correct. And next one that we are going to see, consider the following statement regarding the impact of El Nino on the Indian monsoon. During El Nino, rising air, which is from the Eastern Pacific, rising air shifts toward the Central and what I said that Eastern Pacific, leading to subsidence over the Indian region. Yes, that the rising in the Eastern Pacific, the air which is rising and the part of reverse Walker circulation, it is coming over and it is in a subsidence over the Indian region, and Indian region becoming in high pressure, therefore rainfall relatively more, not very high pressure, relatively high pressure it is, and there because of that our southwest monsoon become weak. And I said the subsidence over the Indian region is taking place. This statement is right. This subsidence enhances cloud formation and increases monsoon rainfall over India. The subsidence causes water vapor to down. The cloud formation cannot take place, very less rainfall, and high pressure does not attract monsoon also, very less. So cloud formation will be very less. It is not enhancing. This statement is what we can say that wrong. So only one statement, the one is only correct. Okay. Now consider the following statement regarding monsoon dynamics during El Nino. Moisture transport from the Arabian Sea and Bay of Bengal increases during El Nino years. During El Nino years, El Nino, no rainfall, less rainfall in India means moisture will go from Arabian Sea and Bay of Bengal less. And here it is saying that moisture transfer from this Bay of Bengal increases and Arabian Sea, no, it is the wrong one. Weakening of the pressure gradient between the Indian Ocean and the Indian landmass leads to the weaker monsoon. Yes, in the over the Indian ocean and in the what I said that in the Indian Ocean, Indian landmass is relatively low pressure intensity reduces because of the descending air. So there is a weakening of pressure gradient between the ocean and the Indian landmass, Indian Ocean and the Indian landmass. So this is in a right one. You can say that only 2 statement is correct. So here, and the next question that we can see, consider the following statement regarding La Niña. And then trade winds over the equatorial Pacific become stronger than normal. Yes, during the La Niña, northeast trade winds, southeast trade become more warmer, and it is dragging more warm water toward the Indonesia and Australia along the Western Pacific. So this statement is correct. Warm water accumulates in the Eastern Pacific Ocean near the Peru coast, and warm water it is talking about. When it is in a dragging from this one, then Western Pacific become more colder, upwelling is taking place near Peru coast. So warm water is not accumulating over there. Warm water is near Australia and Indonesia. So Eastern Pacific talking about is a wrong one. Upwelling of cold water along the South American coast intensifies more. In comparison to normal, La Niña and normal both are same, but I say that in this time trade winds become faster, large amount of water, everything intensified, is stronger Walker circulation. And then there will be, we can say that upwelling of cloud water along the South America. This is the right one, and you can say that cold water is upwelling and during the La Niña. So only 2, that option B, only 2 statements are correct. Consider the following statements about atmospheric and climatic impacts of La Niña. that strengthened Walker circulation leads to increased convection and rainfall over the western Pacific region. Yes, warmer it is there nearby Australia, nearby Indonesia, more rainfall, flood kind of situation everywhere. So this is correct one. And then second, subsidence of air over the eastern Pacific. In the eastern Pacific colder, here the subsidence is contribute to dry condition along the South American coast. Yes, Peru, Atacama desert it is there nearby that. So this statement is what correct. The pressure gradient between eastern and western Pacific strengthens and increasing the intensity of trade winds. So during the La Nina, the pressure gradient between the eastern Pacific, that is a high pressure very high, and a western Pacific very low pressure, it has strengthens and increasing the intensity of the trade winds. Yes, that is a Jerkins feedback, positive feedback mechanism causes more and more Walker circulation keep on becoming stronger, and the trade winds started becoming more and more stronger. So this statement is also correct, and we can say that all the three statements are what right. And in the UPSC 2011, one question has been asked, La Nina is suspected to have caused recent floods in Australia. How is La Nina different from El Nino? La Nina is characterized by unusual cold ocean temperature in the equatorial Indian Ocean. No, it is not equatorial Indian Ocean. It is over the equatorial. Yes, it is in a central and eastern Pacific Ocean. It is in a equatorial eastern Pacific Ocean, not Indian. So this is wrong one. Whereas El Nino is characterized by unusually warm ocean temperature. It's not unusually. Yes, warm ocean temperature in the equatorial Pacific Ocean. The second part is correct, but the first part is wrong. On the basis of that, this statement is wrong. El Nino has an adverse effect on the southwest monsoon of India, but La Nina has no. Yes, to an extent you can say that adverse, not good impact on the monsoon, Indian monsoon is reducing. This part to an extent it is correct, but La Nina has no effect. La Nina brings more rainfall in India, yes or not? The stronger Walker circulation and it is causing. So La Nina brings more rainfall, it has a very high impact. And here this statement, La Nina has no effect on the Indian monsoon. This part is wrong. So this is wrong. So we can say that option D, neither 1 or not 2. Now here we are going to see that what we are going to do in the 12th episode. It is talking about what is El Nino Modoki. It is not El Nino. It is what is El Nino Modoki. And thereafter we will see horizontal and vertical structure of tropical cyclone. And then we will see also horizontal and vertical structure of extratropical cyclone, means mid latitude cyclone, or you can say that temperate cyclone. These are the extratropical cyclone has, it is itself known as a temperate cyclone, and thermodynamic differences between tropical cyclone and extratropical cyclone. And then we will see linkage of jet stream with extratropical cyclone, means temperate, and linkage of jet stream with the tropical cyclone, how it is affecting and all. So we will see about it. And then now here we are talking about why El Nino Modoki happens. You know that when the trade winds are stronger, then the warm water accumulate near to the water near Australia. But during the El Nino Modoki, what is happening? That the trade winds become weaker, so the water accumulated in this region start moving towards eastern Pacific. But it is not able to reach eastern Pacific. Only this warm water is able to reach central Pacific. So when it is returning back, the central Pacific is warmer, western Pacific is cooler, and this warm water is in the next 1, 2, 3 years it is able to reach here. By the time eastern Pacific is cooler, and here it is in a high pressure, here it is in a high pressure, and here this one is in a central Pacific is what? Low pressure. So El Nino Modoki has what? Central Pacific is warmer because of the water which is returning back because of the weak trade winds, and thereafter we can say there is a high pressure, there is cool. Western and eastern Pacific is cool and central Pacific is warmer. When it is in a warmer, this region will have a low pressure, and this region will have a relatively high pressure. This region will have relatively high pressure. There will be upwelling, and if it is high pressure, in high pressure region air must descend down. Yes or not? Here, therefore high pressure also. Here the air moves up, and here it creates a low pressure, and then air moves up, it creates a high pressure. If it is 500 MB, now it becomes this 500 everywhere, it become 600 MB. Now this is 500, this 500, so related to this it will become low pressure. Related to this it will become low pressure, then the wind started moving this direction, and after becoming heavy now start descending, and on the ground there is a high pressure to the water, low pressure. So in case of El Nino Modoki, there is a 2, I said that circulation has been found. So the thermocline changes centered in the Central Pacific. Here is a warmer. Eastern Pacific still allows cold upwelling. Eastern cold upwelling is going on, but slowly this warm water will be able to reach north to the Eastern Pacific in the 1, 2, 3 years. And now, so in the Central Pacific, warm water is rising up, and it is in a water cloud formation, this side rainfall, and where there is an air, you can see that it is a descending down. In this one descending, there will be a water dry condition, no rainfall. Here the air is sinking here in the Western Pacific, and in the water Eastern Pacific, it is in a sinking, air is descending down. And I can say that yes, Modoki Walker circulation, El Nino Modoki, here the air is rising, and here you can say that air is what we can say that it is going, yes, this side, and here it is descending in this region, and then this way it is what circulation is going on. So here the circulation is going like that. Here you can say that a little bit, here the air is descending down one like that, it is going in this direction, and here it is coming. So the double, you can say there is this side it is in a warmer, Western Pacific is cooler, Eastern Pacific is cooler, Central Pacific is warmer. Double sail Walker circulation will be there. There is a double sail Walker circulation. So consider the following statement regarding El Nino Modoki. It is characterized by warming of sea surface temperature in the Central Pacific Ocean, while the Eastern and Western Pacific remains relatively cooler. So this statement, yes, it is an but you have to see whether it is right or wrong, and that it is yes, you have to write in the what I said, that you have to answer this question for the 13th episode. And here the second statement I am talking about, trade winds completely collapse during El Nino Modoki events. Completely or weak, you have to answer that accordingly. Cold water upwelling along the Eastern Pacific is not completely suppressed during El Nino Modoki. So you have to say that which statements are correct accordingly. And now that with reference to the atmospheric circulation during El Nino Modoki, consider the following statement. Convection is concentrated over the Central Pacific, first statement. Second statement, a double sail Walker circulation develops with sinking air over both Eastern and Western Pacific region. And then third, I said that descending air occurs predominantly over the Eastern Pacific Ocean, similar to typical El Nino event. So that we have to say that whether it is right or wrong, which options are, and I am waiting for your answer in the what I said that in the your in the comment box, and I will answer about it in the 13th episode. Yes. And here now that we are going to see the horizontal structure of the tropical cyclone, and here vertical structure of the tropical cyclone. Horizontal, in the center, you know that eye is existing in the center of the ocean. In the cyclone, eye is there, and this eye, if I am talking about this eye, does not develop in every cyclone. This eye developed only in the developed tropical cyclone, which cyclone is very stronger one. In that there is what eye develops. Is it okay? And surrounding eye, there is what I said that eye wall is there, where there is an eye is there in the center eye, where there is no wind is there. In this eye, there is no wind is moving. Surrounding eye wall is there, where the wind is moving very fast, along with the cumulonimbus cloud and cumulus cloud. Only the two cloud, cumulus and cumulonimbus cloud, where it is going upward. And this whole structure in the center, this is an eye, there is nothing but some air is to descend in the eye. It is this eye is what I said that warmer than the surrounding 8 degree to 10 degree Celsius. You can say that warmer than surrounding, because in this region latent heat of condensation, whatever the water vapor has, suppose heat is coming onto the ocean surface, and then ocean surface become warmer. When the ocean surface become warmer, this warm sea surface started going up, then the heat absorbed within the water vapor. When the water vapor goes up and it condenses into water droplets, convert into cloud, then they release heat, and that release heat is known as a latent heat of condensation. So in the cyclone, that kind of things are very high. Yes, because for the formation of ocean, for the formation of what I said that tropical cyclone, there is a need of sea surface temperature should be more than 26.5 degrees Celsius or 27 degrees Celsius, and till the depth of 50 to 60 meters. Such a large amount of hot water. Those hot water going up, that is releasing latent heat of condensation. That is this release latent heat of condensation making I to be what I said that more warmer than surrounding. So here I is in a warmer than surrounding, and it is in a, but there is no wind is moving, you can say it is in a calm, but some air is to descend down, some air it is used to descend down, and then in this region there is no cloud formation, clear sky. But surrounding region is eye wall where the winds are moving, intense convection means wind is spiraling and moving upward, intense convection, maximum winds, and the rainfall, heavy rainfall, cumulus, cumulonimbus cloud, and after that there is several spiral rain bands are there. The whole it is in a moving, this is an eye, around eye wall is there, cloud, cumulus, cumulonimbus cloud, and around all circular there is what it is in a inner spiral rain band, farther it is an outer spiral rain band, and it can be what I said that 400, 500 kilometer, this kind of 600 kilometer wider this structure. In the top it will be what I said that clouds are moving away. When the air goes up from here, then it goes away in this direction in the formation. If below it is in an anti-clockwise fashion, upper it is in a clockwise fashion, the air will go away. And in this condition, there is you know that there is a front formation in the temperate cyclone in the mid latitude along the 30 to 60 degree latitude where there is a warm wind comes and then cold winds. When the two different temperature wind comes, then there is a formation of what are two different temperature, two different pressure wind, two different humidity wind comes, that they do not meet with each other and they creates in a front. Yes or not? But in this case, there is nothing, only warmness is more important, sea surface temperature is more important in the tropical cyclone. So there is no warm front, there is no cold front, there is no front formation in the case of what we can say that tropical cyclone. You can say that in the tropical cyclone, no warm, no cold front, air mass is thermally homogeneous everywhere. There is a temperature, it is what I can say that homogeneous, you can say. Strong radial organization around the center. This is we have talked about eye wall, inner spiral rain band, and what I said that outer spiral rain band, and at the end the air used to what I said that subside here. It is what we can say that horizontal structure, and in the vertical structure if I say that in this region the low pressure center aligns from the surface upper atmosphere. Here the low pressure is there which is going upward, and after that there is this is an I1, the low pressure system it is existing, and it is also known as a barotropic. It is also known as a barotropic strong system, and everywhere it is I said that a strong barotropic system is there. Means everywhere same kind of what I said that low pressure is, I said that pressure depends upon the density. It is known as a barotropic in the tropical region, barotropic. When the pressure depends upon the density of the air, it is known as a barotropic, and from the down to up, everywhere the strong barotropic is there, and because of the barotropic, shear force means sometimes this is in a vertical structure of the what I said that it is in a vertical structure of the cyclone. If it is I said that shear force is more, then it will take away this upper surface and cyclone will die and it will not be able to develop. So shear force means I said that somewhere in the ground another force and upper side another force. But when the cyclone keeps on moving and they keep on rotating together and eye wall everything together it moves. But suppose upper surface area moved faster, that is known as a shear force is high and then cyclone death will occur. So for a strong barotropic creates a low shear winds, a strong, it is in a barotropic, from there it is in a what a pressure system which is I said that very strong, a strong barotropic. So there is in a minimal shear. But if there is in a what I said that barotropic is weak, then it is in a strong shear, upper structure of the cyclone will removed away and cyclone death will occur. So, and thereafter you can say that this is an eye region, there is some subsidence is taking place. Intense barotropic structure informed with the height, it is uniformly, it is all along, and intense convection within the eye wall there is a convection, the wind which is moving along with the cloud, cumulonimbus cloud, and the rainfall take place. So you can say that out here is an inflow of from the outside, air is coming in this region and then circulating around the eye. Eye can form only in the developed cyclone. This is the vertical structure we have seen. Now, what is there? I said that based on this one, consider the following statement regarding tropical cyclone. They are characterized by the pressure of well-defined warm and cold fronts. What do you think? In tropical cyclone, is there in warm front and cold front? So they exhibit, second statement, they exhibit an what I said that vertically aligned structure with low pressure centers, low pressure center extending from the surface to the upper atmosphere. We have to say that upper till troposphere. And second statement, and then third statement, their structure is largely symmetrical with a well developed eye and what? Eye wall, everything. So there is what we have to see that which statement is what I said that which options can be correct according to this statement. So we have to answer it. I am waiting in the next. But in the mid latitude, you can say that warm westerlies in the mid latitude, 30 to 60 degree latitude, you can say that warm westerlies coming from subtropical high pressure region, and then cold polar westerlies from the coming from the what I said that polar region comes, and they have a different temperature, they have a different pressure, they have a different humidity. Cold air has what I said that high pressure, and cold air can hold less moisture. Cold air has, I can say that temperature is less, and temperature less, high pressure, less moisture, less humidity. And warm air, warm westerlies which are coming, that warm westerlies, as I said, that high temperature, it can because expanded air is and it can hold more moisture, and it can hold more moisture means more humidity, and it has a low pressure. So when this different temperature, the temperature, cold air has a different temperature, pressure, humidity, warm air has a different kind of temperature, humidity. So when they come into this region in the 30 to 60 degree latitude, in that region they are not able to meet because of the different and different contrasting nature. They do not intermix and creates a front. And where there is what I said that when there is a very on the western side, especially if I am talking about the western side of the what there is a formation of temperate cyclone, this cold front, warm front, occluded front. There is I said that when these are happening, that on the western side it is cold fronts are forming, and it is I said that cold dense air mass is there, and in this region we can be able to say, like I said, that in this cold dense air mass it is moving faster on the ground, and then warm air mass from the warm westerlies, it is started rising up and create a cumulonimbus cloud of the 10 to 12 kilometer height, and it is causing what I said that very heavy rainfall. But here who is giving more pressure? Cold air mass is giving more pressure and invading into the region of warm air mass, therefore it is known as a cold front, and there is a cumulonimbus cloud, and heavy rainfall is taking place, and sometimes of what here cirrus clouds are. So in this region, sudden drop when the cold and this cold ocean, this cold what I said that air mass which is moving faster, where it is going in that region, suddenly the temperature decreases faster. So sudden drop in temperature, sudden you can say that when the cold front is passing through this one, sudden drop in the temperature, wind shifts from often to northwest direction. It is I said that in which direction, you can say in the northern hemisphere we are talking about shift to the northwest direction. Here upward warm air is moving this side, and the cold air is moving on the ground, and a strong gust, it is moving faster, therefore gust is the wind filling is more. Heavy rain storms, this side cumulonimbus cloud is always I said that heaviest rainfall cloud, and potentially if it is going upward, some I said that ice crystal will form, and there is a hail stones can form down, and then hail storms it will be there, and that you can say potentially hail will be there, and rapidly falling pressure where it is going down, making that I said region to be very colder and high pressure region, that makes it what rapidly what falling of the pressure when it is going. And after the front, what happened when it has gone away? The sky is clear, humidity become lower, temperature become very low, that region is colder, and stabilizing atmosphere and increasing what? Pressure. Is it okay? So here now the warm front is what I said that here the warm front on the eastern side, you can say that here warm air mass is invading, and this cold air is this in the cold front, cold air is much more colder in cold front, and in the warm front cold air is what I said that relatively less. Here in the cold front, cold air mass is invading and the warm air mass is rising, but in the warm front, warm air mass is I said that invading and into the cold air mass, and here it is rising upward, and then you can be able to say that there is a formation of what different kind of from the ground. You can be able to say there is what stratus cloud, alto stratus cloud, nimbo stratus cloud, cirrus clouds, like that it will form, and its slope is also less. Here you can be able to say that this is known as in this region what drizzle and sometimes rainfall takes place along the warm front. So this is now again here who is invading? Warm air mass is invading. On the basis of that one, he is the stronger one, warm air mass, therefore rather than the cold front. So here it is considered in a what a warm front, because who is invading? Warm air mass. And you can say that there is an occluded front. If I am talking about in case of occluded front, what is happening that when the cold air mass of the cold front and the warm air mass of the what when the cold front and warm front come together, in the cold front also warm air mass is rising up, converting into cumulus clouds, cumulonimbus, and in the warm front also warm air mass is always lighter one, and then it is moving upward. So when the cold front and the warm front coming together, then the ground in the cold front also cold air mass on the ground, warm air mass is up in the cold air front, and in the warm front warm air mass is up, making what altostratus, nimbostratus, cirrostratus, different kind of clouds, yes, along the warm front, and here it is coming along that. So when they are meeting, so the ground is covered by the what cold and warmer is above, and there is a heavy rainfall. Cold front side, what you can say that cumulonimbus cloud, and then warm front side, yes, there is an altostratus, nimbostratus, and you can say that cirrostratus, different kind of clouds, and then drizzle rate is taking place, and overall heavy rainfall keeps on happening. And when the occluded means covered, occluded means you can be able to say that covered. The ground is covered by the cold, upper surface is covered by the warm, and you can be able to say that this kind of a structure, this is known as a cold, this triangular structure is known as a cold front type of it, and here you can be able to say there is what cold front is going on and warm front coming together, and there is an occlusion can be taken place. So this is what I can say that this is a cold front, this is a warm front, they get, and occluded has been taken place. This ground is covered by the cold, and here it is in a cumulonimbus cloud, here it is in a altostratus, nimbostratus, cirrostratus cloud, and there is what they get together, and that is known as an occluded, and after that death of temperate cyclone takes place. So cold front, warm front, occluded front is a part of temperate cyclone or extra tropical cyclone. In that condition, like you know that in the case of tropical cyclone, there was an eye at the center. There is no as such eye, as it is fixed. Yes, low pressure exists, but not like an eye things are there. Use it in the extra tropical cyclone. It is based on cold front, warm front, and occluded front. It is okay. Cold front, cold air mass invaded into the warm air mass, and then warm air has rising up, and cumulonimbus cloud faster cold front. And in the warm front, warm air mass is invading into the what colder air, and then it is not colder, cool air relatively less, and it is rising up, creating a what slope is also very less, and it is making a kind of what altostratus, nimbostratus, cirrostratus cloud, drizzle and some rainfall. But cold front has very high rainfall and much faster also. When both are meeting, so the cold air of cold front and cold air of warm front, both the ground covered, and when they are meeting and the warm air goes up and covered means occluded, and after that the cyclone get the temperate cyclone formation finishes with the help of when the first time when the warm air westerlies and cold polar easterlies form, and that is known as a stationary front. It is not over there in this topic, but when the first meets stationary front, from there after cyclone, temperate cyclone or extratropical cyclone formation starts. So all the things that I am talking about is about the extratropical cyclone. And tropical cyclone, what we have seen, there is a circular structure, something like that. There is an eye wall, inner spiral band, outer spiral band. There is nothing. There is an, I said that structure, you can be able to say, like I say, what I said that this is a structure, you can say that V shape, inverted V shape, or you can say that comma type. This kind of shape you can say. Inverted V shape. So tropical cyclone, what you can say that what is happening, there is a what you can say, there is an eye, there is an eye wall, and the intense convection, maximum winds in the eye wall, and spiral, inner spiral band, outer spiral band, and there is a low pressure from the top to down. Low pressure center aligns from the surface to the upper atmosphere, it is going on, and minimum vertical wind shear. Wind shear is very less because a strong barotropic is there, and in this one there is a baroclinic. Here we can say there is a warm front, it is there. Here the warm front, and one side is, I said that warm front gradual uplift. In the warm front, warm air mass is gradually uplifting, and in the cold front there is a steep. We have shown you it is a suddenly rising steep uplift, and strong horizontal contrast dominate structures. And here the tilted westward height. So this side is you can say that this one, if I am talking about where the cold front is on the western side. So tilted westward side it is there, and there you can say that occluded front, it is in a mature stage after the cyclone finishes. Baroclinic structure varies with height. Yes or not? Baroclinic. In the tropical cyclone I talked about barotropic. Here I am talking about baroclinic. Baroclinic means in the barotropic I said that pressure depends upon density, and everywhere I said that is stronger one. Yes or not? In the baroclinic, pressure depends upon temperature and density. Remember that, temperature and, because there is a cold air mass one side, a warm air mass. So there is not, I said that it is not exactly, it is varies with height. In the different region, cold front, warm front, here it is in a varies with height. So I said that if it is varies with height, clearly defined frontal boundaries. Yadi, if it is changing, means it means somewhere temperature. Cold front has this, cold air mass has different temperature, warm air mass has different temperature, warm air has different density, air is expanded, cold air has air is what I said that denser, it is in a contracted. So there is in a this clearly defines that yes, there is in a frontal boundaries are there. Baroclinic defines frontal boundaries. Interaction of contrasting air masses, warm versus cold, means warm westerlies and cold polar westerlies are there. And here that consider the following statement regarding extratropical cyclone, means temperate cyclone, and they have a baroclinic structure. Means extratropical means warm front, cold front. They have a baroclinic structure with the significant variation in temperature and pressure with height. Next one, they are second statement, they are associated with the frontal system such as warm fronts and cold fronts and occluded fronts. They possess a highly symmetrical circular structure with similar to tropical cyclone has a circular, it has, I have said that what kind of shape, is it okay? And here now we are going to see that thermodynamic differences between the tropical and extratropical cyclone, and here you can be able to say that first of all, warm ocean heat moisture means that the temperature of the ocean should be more than 26.5 degrees Celsius or more. It can be 27, maybe 28 until the depth of 50 to 60 meter, and this air rises, condensation and latent heat release, whatever I have discussed right now, when it is going upward, that heat is released, latent heat which is hidden inside it is releasing, and heat warms the core, and because of that this latent heat, it is warming the core, means making the central region to be warmer, and slowly it will develop into eye, and when the heat warms the core, lower the pressure further in the center, lower the pressure is decreasing and help in moving the wind faster toward the center because of the latent heat, and the center strong inflow. If it is in a low pressure, inflow will be more, and it will intensify the system. Self-sustaining positive feedback means once the latent heat, low pressure become, more water vapor is coming, more water vapor, more latent heat of condition, more release. So self-sustaining feedback means it is keep on increasing until unless sea is giving warm water, and those warm water vapor converting into what I say that releasing, it is going upward cloud and releasing latent heat of condensation. It is like a chain reaction keep on happening. If it is able to reach any land part, in the land part you can be able to say that there is no supply of warm water from the below, then the death of cyclone can occur. You can say, and here you can say maximum warming in the upper troposphere. Here in this region there is a maximum, here it is goes up, in this region maximum warming known as warm core of the cyclone, and it is known as an atmosphere in upper cyclone, and you can say that this is in a kind of upper cyclone structure. And summary, if I said that latent heat is very much important for which one I said that for tropical cyclone formation, and we can say that latent heat of condensation, we can say that latent heat of condensation in the eye wall, we can say latent heat of condensation, latent heat of condensation is very much important for the, I said that eye of the cyclone formation and all. and then cyclone formation. Continuous evaporation from the warm, this the temperature should be what I said, that 26 to 27, and everywhere it is written somewhere 26.5 degrees Celsius or more, or somewhere it is written like 27 degrees Celsius or more, even then it is also correct. Thermal structure, core warming than the surrounding. Core section, the eye of the region is 8 to 10 degrees Celsius warmer than the surrounding. And then we can say stability requires what? High humidity, means sea surface keep on giving more water vapor. Low vertical wind shear, there is wind shear means barotropic should be stronger, so that the vertical structure of the cyclone can remain there. Condition instability, so it is known as an unstable air mass. Unstable air mass means warmer air moves up, it is known as the unstable. Cold air remains near to the ground, it is known as stable. So in this region, for the formation of tropical cyclone, there is a continuous need of what you can say that uplifting of warm air upward. It is okay. And in the case of what I can say that cold front and what I say that extra tropical cyclone and cold front, warm front, here a strong temperature contrast. One is in cold polar easterlies and one is going from the tropical subtropical region warm easterlies. Wave develops along the front. When they are meeting, there is what I said that first stationary front, then thereafter cold front and the warm front. There is a development of wave like that. So wave develop and warmer air rises over the cold air. In the warm front also warmer air rises, and cold air undercuts warm air. Cold air from the below, cold air is moving and warm air is moving upward. And cyclone intensified through the energy convergence, and when there is a warm air, it is keep going upward and giving, and I said that releasing some latent heat also it is causing, but that energy is not required. Temperature contrast, cold air has low temperature and the warm air has high temperature, that helps in the formation of tropical cyclone. So thermal structure, cold core at the lower levels. If where there is meeting in the center of that, there is a cold core. Remember, in the tropical cyclone, I is warmer than the surrounding, very high, and in this one central part is cold, and because of the cold front and warm front where it is meeting, the ground is covered by cold front and warm front, ground is covered by the cold air, upper is warm. So and near to the ground you can see that there is occluded front, and this region colder air in the near to the ground. So a strong horizontal temperature gradient, you can say. Stability condition exists in the dynamically and unstable atmosphere. Stability, ground में stability है, ऊपर में instability is there. So and it is associated with the polar front jet stream, and here you can say that temperature, horizontal temperature gradient. One side is in a cold air, another is in a warm air. So there is a more low temperature and a warm temperature toward the warm. So horizontal temperature gradient you can say, and that helps in the increasing the kinetic energy of it. And the mechanism is strong temperature contrast, that is over there. Cold air has a very low temperature, cold, and here it is in a warm. Temperature contrast, wave develops along that. So here you can be able to say that in this region, and here tropical cyclone has warm core, extra tropical cyclone has cold core. It is a symmetrical. From the center it is an eye and eye wall and all, everywhere it is symmetrical, but this is in a V shape, inverted V shape, asymmetrical. And front, in this region front does not exist, in this region front exists in the extratropical. And vertical alignment, it is in a vertical alignment, but in this case of extratropical cyclone, tiltation is there. Here it is in a energy source is latent heat, here pyroclinic instability is important, and wind maximum in the eye wall where the winds are moving faster and cumulonimbus cloud. Here the winds are along the fronts, and the rainfall intense and localized. Particular reason where it is goes, but it is in a very large area. Front temperate cyclone is 500 to 2500 kilometer, and tropical cyclone is 500, 200, 300 kilometer wide. So it is very large area, widespread and stratiform. And size is smaller, and its size is cold. Extratropical cyclone size is larger, and in tropics it is happening between 5 degree to 20 degree north and southern hemisphere. It is occurring between in the mid latitude 30 to 60 degree. So on the basis of that, consider the following statement regarding the tropical cyclone. Here we can say that they derive their energy primarily from the, I am talking about regarding tropical cyclone, temperature based, thermodynamics based. They derive their energy primarily from the latent heat released during the condensation over the warm ocean water. Where it is going upward and there is a latent heat of condensation, it releases heat. So you have to say whether it is right or wrong. They are characterized by cold core structure with a strong horizontal temperature. In the tropical cyclone, whether it is right or wrong, you have to say. And thereafter, we are going to see the next one, the linkage of polar front jet stream with the extratropical cyclone. You know that extratropical cyclone, which is forming by the front, cold front or warm front, and when it is forming, you can say there is a warm sterlies are there, and here it is in a cold polar sterlies are there, and in this region cold polar sterlies and it is in a warm. So along that, when it is forming, above that warm air rises, and here it is in a polar front jet stream forms. Above in the upper atmosphere, fast moving winds forms, and where there is some major, there is a wavy structure start taking, there is a cold front forms. Initially it is in a stationary front, but here that cold front forms, and here is a warm front. In between this low pressure, air rises up. At the cold front, warm air is rising up. In the warm front, warm air is rising up. When it is rising up, here it is making more high pressure, and the wind is very fast in this region. And when in the polar front jet stream, here the wind can reach up to 500 km/h, and that is known as a jet streak. And this low pressure and jet streak drags the cyclone, temperate cyclone, from the water west to east. This temperate cyclone has been, this low pressure is dragging this west to east. It is okay, tropical cyclone, and warm front is there, and there is what I can say that occluded front. Here is the low pressure, it is dragged by the water, that we can say that jet streak create a divergence aloft. If it is going upon and it is causing divergence, faster moving away, divergence in the upper away, and here an extratropical cyclone form along the polar front jet stream, and it moves from the west to east. It is moving from the what you can say that west to east. So this is I am talking about, yes, polar front jet stream is associated with the extratropical cyclone, and it drags along the west to east, and jet streak is very much important, where the wind speed is very fast because of the upward air moving, and air is diverging aloft faster. Here linkage of jet stream with the extratropical formation means where the formation of temperate cyclone is happening, low pressure, that is cyclogenesis. Extratropical cyclones forms along the polar front. Polar front jet streams creates, why? Upper level divergence faster. Surface pressure falls. Here you can see that there is a surface pressure is what? Falling. When it is going upward, anywhere the air moves upward, surface air will be also dragging more and the falls. And then initiates cyclone development, and after that the cyclone development starts. Intensification, who intensify? If there is a jet streak is there, which is making the faster, more air moving up, then the temperate extratropical cyclone intensity increases. Jet streaks creates divergence in the upper, air started rising more from the ground, and then more low pressure, and then on the ground, and there is there is no I in the temperate cyclone or extratropical, but it is a deepening of the low pressure, which enhances baroclinic instability. Means temperature changes with height, density also changes with the height in the mist. It is affecting the pressure system. Now, who is steering mechanism? Who is dragging it? Who is driving it? Upper atmosphere, the jet stream drag it from the west to east, and the speed of cyclone depends upon that. So here we have to answer this question. Consider the following statements regarding formation and intensification of extratropical cyclone, means temperate cyclone or mid latitude. Upper level divergence associated with the jet stream can lead to fall in surface pressure and initiate cyclogenesis, means starting of cyclone. Second statement, jet streams act as a steering mechanism controlling the path. It is controlling the path and speed of extratropical cyclone. Now you have to answer that question in the comment box, and I am waiting for your answer for that. Now we have to see linkage of jet stream with the tropical cyclone. Linkage of tropical cyclone which is forming in India, you know that everywhere in the Arabian Sea, Bay of Bengal, more formation of Bay of Bengal tropical cyclone, but now Arabian Sea is becoming more warmer, tropical cyclone is forming more in the now Arabian Sea also. So what is happening? There is a tropical cyclone is there, and you know that we have discussed in the earlier video that subtropical westerly jet stream, when it is coming in the contact of westerly jet stream, then upper structure, because of that shear force will increase and upper surface can be removed away. So high vertical wind shear, if the jet stream, strong upper layer jet stream will be there, then what will happen? It can cause, I said, that disrupts the vertical structure and prevent latent heat of condensation. If the vertical structure has been moved away, so niche from the below, the upward movement of water vapor will stop and the death of cyclone, latent heat of condensation will not take place. Yes, that inhibits the formation. Strong jet streams created vertical wind shear, create very high vertical wind shear, means top to be removed and the lower will be, yes, remain there, and inhibits storm development, means cyclone development will stop. And here further we can be able to say that enhanced upper level outflow. If there is an outflow in the tropical cyclone, if there is a very high flow, you will be there, shear force will increase and then cyclone can also die. So dual channel outflow can be there and what I said that it will intensify cyclone. Enhanced upper level outflow, dual channel. Here it is a one, this is outflow, this outflow. It is a dual channel and it will structural tearing, means this outflow of jet stream moving away and this outflow, they will tear away the cyclone and there will be the death of cyclone, rapid weakening. You can say that a strong jet extraction. So here moderate upper level, if the outflow is moderate, cyclone will be stronger. If the outflow is stronger along with the jet stream, it will shear force increase and the top cyclone will top of the cyclone will tear it away. Moderate upper level outflow links, dual channel outflow can enhance cyclone strength, but a strong direct jet stream interaction creates high shear, can tear the cyclone structure, vertical structure, and the latent heat of condensation will not occur. Sometimes you know that this is in a subtropical jet stream and this is in a subtropical westerly jet stream and this is in a tropical cyclone, and this tropical cyclone is moving. Sometimes when it is coming in this region, sometimes that it drags to the water northward, then that drags started, why I say that it started dragging further eastward, and then when it started dragging north to east, it is in the 5 degree to 20 degree. Temperature required this, everything this one. Now, but sometimes this subtropical jet stream drag it to the colder region and this recurvature is taking place. It has been gone into the 30 to 60 degree region where the extratropical cyclone is there. Sometimes this subtropical westerly jet stream drag it eastward and recurvature is taking place and then it becomes a temperate cyclone, extratropical cyclone. Tropical cyclone convert into extratropical cyclone, means extratropical transition it will be there. So here tropical cyclone interaction, that what happened, asymmetric transformation will take place because of this jet stream and it will, what I said, that convert into what it is in a subtropical jet stream here, like in a front kind of it, cold front, warm front. So linkage of jet stream with the tropical cyclone, I am talking about one, it is it can remove the vertical structure, and we have seen also that formation condition. Tropical cyclone forms over the low vertical wind shear. Everywhere wind shear should be very low. If they are stronger, the structure is disturbed. A strong jet stream, high shear inhibit formation. Second, intensification and weakening. If the upper air divergence aloft is moderate, the intensified. If the moderate upper layer outflow, then it is an enhanced cyclone strength. If a strong jet interaction and a strong uplift aloft, there will be what it can tear away cyclone structure. And after that we can say that recurvature, a cyclone move poleward, they encounter westerly jet stream. Sometimes it is moving poleward like that, taking the path and encounter westerly jet stream, subtropical westerly jet stream, then it drags westward first, yes or not, and then further northward and then eastward. It is known as a recurvature. Westward, then northward, then eastward, it becomes extratropical cyclone. Now it converts into this tropical cyclone, enters mid latitude and interacts with the jet stream over there and front transform into extratropical cyclone. So on the basis of that, you have to see this question. Consider the following statement regarding the role of jet stream in the tropical cyclone formation. A strong jet stream can inhibit the formation of tropical cyclone by increasing vertical wind shear. That we have to say whether it is right or wrong. Tropical cyclones require high vertical wind shear for their development and intensification. You have to answer it in the comment box. And the next question that in UPSC 2020 it has been asked that jet stream occur in northern hemisphere only. Jet stream occur in every hemisphere. Whether it is in a northern and southern hemisphere, everywhere what I said that it is there. And only some cyclone develop an eye. I have said that only eye develop when there is a very developed tropical cyclone is there. The temperature inside the eye of cyclone is nearly 10 degrees Celsius lesser than that of the surrounding. So accordingly, you have to see that whether it is in a right or wrong. I am waiting for your answers in the next question. In the next episode of 13th episode when we'll try to cover each and every, I said that aspects of other part of the geography also, and keep on enjoying and keep on giving comments. And if you like this video that is which we are giving at the Drishti online platform, so please keep on subscribing and keep on enjoying with us. We'll meet further in the next class. Till then.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.